Okay, 2012 AMC. This was problem 14 from the AMC10A, and it says Chubby makes non-standard checkerboards that have 31 squares on each side. The checkerboards have a black square in every corner and alternate red and black squares along every row and column. How many black squares are there on such a checkerboard? Well, I could draw a checkerboard, and after I solve the problem, I'll give a diagram to explain what I'm doing so you can skip it if you get it. But basically the idea is, so if there are 31 squares, and it always alternates red and black, we'll either go like black, red, all the way on to a black square. So we'll either have 16 black squares and 15 red squares, or on the other one, since the row after this, or the column if we're looking at that, they work the same way, we'll start with red and end in red. We'll have 16 red and 15 black. Okay, and so each row, this is what we're talking about, each row will be one of these situations. And we know that, so since we start with a black square and we end with a black square, we know that we will have a total of 16 rows with 16 black squares. And then in between those, we'll have 15 other rows, so we'll have 15 rows with 15 black squares. And this is really nice because we should know our perfect squares. 16 times 16 is 256. 15 times 15 is 225. And 256 plus 225, if my math is correct, should give me 481. And my answer is B. Okay, for those of you that need a little bit more of an explanation on that, what's happening here, let's look at the 5 by 5 situation, okay? Because we can see that, we can count them, we can see what's going on much better here. Okay, and what it's saying here is that we have it alternating like this with red and black squares. And every corner is black. And from here you can see that we have, in this 5 by 5 case, 3 rows with the 3 black squares, which is which we would round up for, and we have 2 rows with 2 black squares, and you can see how we could come up with this product and add together, get our answer.